Well, for the past few chapter sections, we've been looking at solving systems of equations, and we've used various methods. We've used graphing. We've solved systems of equations using substitution. We've also looked at solving systems of equation with elimination using addition, subtraction, and multiplication. And so we're going to work through a few examples. In fact, I'm going to be working through the examples on page 365 in your textbook. There's 4 problems there. And we're going to take a look at which method we might best use. And the truth of the matter is we can use just about any of those methods on any equation, but some of them kind of fit better than others. So let's take a look here at the first one. We've got 2 equations. We got one that's 5x plus 7y equals 2. And the second equation is negative 2x plus 7y equals 9. Now, at first blush, first look, there may not be. I'm looking. I got a 5x and a negative 2x, so addition and subtraction is not going to work there. And then I got a 7y and a 7y. Well, that's not going to immediately cancel. I don't have a variable by itself to use substitution. But, however, if I were to subtract these 2 equations, I'm going to put this in parentheses. And in essence, when I subtract, I'm actually going to be distributing a negative 1 to everything inside the equation, which has the effect, if you will, of changing the sign. So that would make that a plus 2x, make this a minus 7y, make this a negative 9. And now I can I look at it as adding them, but really we're subtracting them. So let's see, I got, that makes 5x plus 2x, well that's going to be 7x. And then I've got 7y minus 7y, well that's going to be 0y. And then we got 2 and negative 9 is going to give me negative 7. I'm going to divide 7 to both sides, and x is going to equal negative 1. Then, of course, we're going to substitute this negative 1 into either of those equations. I'm going to do the top one, I believe. And so I've got 5 times negative 1 plus 7y equals 2. Well, 5 times negative 1 is negative 5 plus 7y equals 2. Well, now I'm going to add 5 to both sides, and when I do, I'm going to have 7y equals 7. And we're going to divide both sides by 7, and y is equal to 1. And my solution set then is negative 1, 1. So we applied solving the systems of equation using elimination with subtraction. Oh man, we are solving the systems of equations. How cool. All right, let's do another one and we'll see what method we use. All right, we've got 3x minus 4y equals negative 10. And we've got 5x plus 8y equals negative 2. Okay. Well, let's see here. Well, I got a 3x and a 5x. I don't see anything I could use there other than a lot of multiplication. But I do have a negative 4y. Make that a better y. 4y plus an 8y. So I got a positive y and a negative y. So if I were to go in here and multiply this equation, this top equation, by 2, Well, let's see what we would have. So I got 2 times 3x. I'm going to write it right down here. That'd be 6x. 2 times negative 4y is negative 8y. And 2 times negative 10 is negative 20. Okay, and then we got 5x plus 8y equals negative 2. So in order to eliminate that variable, I can multiply by 2 first and then add them together. And when I do, I got 6x plus 5x is 11x. Negative 8y plus 8y, well, that eliminates that variable of a y. It's gone. And now I've got 11x equals negative 22. Divide 11 to both sides, and x is equal to negative 2. Shazam! All right, we're going to go forward then. Let's see. We're going to substitute in negative 2 for x into one of these equations. Which one do we want to use? All right, let's just use the bottom one just for fun. So I got 5 times negative 2 plus 8y equals negative 2. 5 times negative 2 is negative 10 plus 8y equals negative 2. And let's add 10 to both sides. So now we got 8y equals 8. Divide by both sides by 8, and y is equal to 1. And our solution to this system of equations is negative 2, 1. And remember, when we're solving the systems of equation, really what we're doing is we got two linear equations, and this is going to be the point of intersection. This is going to be the point where these two lines cross. So here we used elimination with multiplication to get us a positive and a negative values for y, in this case negative 8y and positive 8y to eliminate the y variable, solve for x, plugged in the value for x to then solve for y to finish off solving the system. Well, all right, 2 more to go. Everybody says, oh man, 2 more to go. I can't take it. All right, let's take a look at another one here. We got x minus y equals 9. And we got 7x plus y equals 7. Now, I could look at that and say, well, if I did a little work, I could do substitution. But certainly, it's going to be much easier just to add these two together. Because when I do, I'm going to cancel, I'm going to eliminate, if you will, this variable y when I got negative y plus y. So let's go. So x plus 7x equals 8x. And the y's have been eliminated or canceled, and 9 plus 7 is 16. We're going to divide both sides by 8, and x is equal to 2. What do we got to do next? Anyone? 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 Bueller? 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 Now we're going to substitute 2 for x in one of these two equations. And I could use the top one, but then I got to divide by negative 1. It doesn't really matter which one I use. I'll tell you what, I'm going to use the bottom equation. So I got 7 times 2. I'm substituting in 2 for x in that second equation, plus y equals 7. 7 times 2 is 14, plus y equals 7. And I'm going to subtract 14 from both sides. That's going to leave me with y equals 7. Negative 14 is going to give me a negative 7, and y is equal to negative 7. And the solution to the system of these two equations is x is 2 and y is negative 7. One other thing to remember when you're writing your ordered pair, and if you solved in terms of x and y, the x value goes first. It goes to the left side in the parentheses, and the y value is always going to go to the right side in the parentheses. And we solve this by eliminating the variable using addition. All right, last one in this lesson. And is there anybody out there that would say, Mr. Williams, please do some more, please do some more, please do some more? I didn't think so. Okay, let's see. We got a couple of equations. We're going to, in our system, we got 5x minus y equals 17. And our second equation, we got 3x plus 2y equals 5. Now, I could use a variety of methods on these. One of these, when I actually look at it, and probably the one I actually would use is maybe multiplication. But I also could use substitution. So let's try that. Now, I'm going to have to do a little work to this top equation to get where I've got a y equal, which is probably why I would actually have used multiplication, but your book wanted to use substitution, so we'll go with that. Now, here's what I could do. If I move this y to this side, that's going to make that a plus y, and if I move this 17 to this side, it's going to be negative 17. So if I do that, then I'm actually going to end up with 5x minus 17 equals y. A little rearranging of that top equation. So now that I've got a y equals, I can substitute in 5x minus 17 for y. So let's do that. So we've got, we'll go to the bottom equation. I've got 3x plus 2 times, and I'm going to substitute this in right down here, 5x minus 17 equals 5. So let's distribute that 2 to the 5x minus 17 first. So now we've got 3x plus 10x minus 34 equals 5. Well, I can combine the 3x and the 10x to 13x. And when I add 34 to both sides, I'm going to end up with 13x equals, that's a negative 34, so it's going to be, I'm adding it, so it's going to be 5 plus 34 is 39. Divide both sides by 13, and x is going to equal 3. All right, so now I can substitute in this 3 for x in either one of these two equations. I still just don't really like that negative y, so I'm going to use the second equation, and then I've got 3 times 3 plus 2y equals 5. Well, 3 times 3 is 9, plus 2y equals 5. Let's subtract 9 from both sides, so that's going to be 2y. Let's see, 5 and negative 9 is going to give me negative 4. Divide by 2 both sides, and y is equal to negative 2. And my solution for this system of equations is x is equal to 3, y is equal to negative 2. And we had to do a little roundabout way of doing that, but we solved that using substitution. How about it? Shazam, we're done.